Proportionality question. So if we look at the first part of the question, it tells us that there is an object that varies inversely with the square of the difference. As soon as you see that language, we know that it's a proportionality question, and we're going to write that out in terms of the exact same order that we're seeing it. So the weight of an object varies inversely proportionally with the square, so inversely is 1 over, with the square of the distance. So that means that we have this relationship where we have weight is proportional to, and then it's an inverse proportion, 1 over d squared, which means that as one is increasing, the other is decreasing. So the first part of the question says that we need to find a model for the weight of the astronaut based on the distance from the center of the Earth. We know that if this is our relationship, we can rewrite this with k so that we can find the specific relationship for this particular question. So W is equal to k over d squared. And then we're looking in the question for a condition that we've been given. So we should have been given somewhere a value of W and D that are equal at the same time so that we can then find k. And we're told that at 6,370 as a distance, the astronaut weighs 600. So that is our condition that we can use. That is our scenario that happens at the same time, where the things are happening at the same time. So the weight is 600, and that's equal to k over d squared. Now that's 6,370 squared. So we're trying to now find what that k value is, because once we know the k value, then we have the relationship or the equation or model for the weight and the distance. So we're going to go to Math, Numeric Solver, and we're going to solve this equation. So 600 is equal to, and then we have a fraction where we have x, or k in this case, over 6,370 squared. So that's to the power of 2. And that power of 2 is just the distance. And if we solve that, we find we have this value, large value, for the value of k. Now you can write the exact number, or you can round it to 3 significant figures. I'm going to write down the full number. So that gives me 2434614 and 0000. And I can just put my commas in here. You don't need to do this. And then from there we can create our full model. So W is equal to, and I'm just getting that from here, W is equal to, I now know k, so I can write this in. Over d squared. Now don't be put off because that seems a large number. We can always look at it in the context of the question. If we're talking about distances from the center of the Earth, we're expecting these values to be quite large. So now we're looking at the International Space Station, which orbits at an altitude of 408. So that means that the distance has something to do with 408. And we're trying to find the weight of an astronaut that's on board the space station. So we're going to be using the formula that we had earlier. So the weight is equal to 2434614,000, and this is all over the distance squared. Now the distance, it says that they're 408 above the sea level, but we were also told that at sea level, if we go back to the beginning of the question, at sea level, which is this amount from Earth. So that means that the distance of the space center is actually 408 above sea level, which is 6,370. And that gives me a total of 6,778. So that's actually how far away we are. So that's the distance squared. And then we can use our calculator to find what that value is. So we can see here that we can just type in the 2434 614 0000 divided by, and then we have 6778 squared. And it's just that last part there that is squared. So I should probably put a bracket in. So I'm just inserting an extra bracket. And we can see there that the answer is 529.9. There we go, which is newtons. And I can rewrite that to 3 significant figures, which is therefore 530. And then for the last part, it's required, find the required distance from the centre of Earth, where the astronaut weighs half of what she weighed at sea level. So at sea level, we were told right at the beginning of the question, they weighed 600. So if it's half of what they weighed at sea level, we're interested in a weight of 300 newtons. So 300. And we want to find what distance is that. So this time we know the weight, which is 300. And then we use our same formula again. It's always the same formula. So we said in lesson that these questions, it's always going to be a condition so that you can find this relationship and the K value. Once you have that formula, you're just going to be substituting it in to find the various parts. So we can now go back to numeric solver and we can find out when it's equal to 300, and we have a fraction with our 2434 614 000 over, and then here we have our x squared. We can find out what this is equal to, and we get an answer there of 9,008.5. kilometers, or to 3 significant figures, that would be, there we go, 9,010 kilometers. So in terms of the marks for this question, for the first part it was out of 2, so one of them is for correctly substituting in and trying to find the K value, and the other is for the final answer. And then we have for the second part again 2 marks, and one of them is for substituting in, so substituting in here, or even if you just found this, then that is the first method mark, and then there is one for the answer. And for the third question, it's 2 marks again. So one is for the 300 and then substituting that value in, and one is for the final answer. So you can see there what you needed to write for the 6 marks of that question.